We're asked to solve the equation sine of 2x minus 1 is equal to 0 for its principal angle. And this isn't going to be that hard, but there's sort of a seductive path that you want to avoid. It might occur to you that we have a double angle formula, and we can say that sine of 2x equals 2 sine x cosine x, which is certainly true, although it's not in this case going to prove to be very useful. Cleaning up this just a little bit. If we put that in, we would have that 2 sine x cosine x minus 1 equals 0. And then you might be tempted to bring over the 1 and say 2 sine x cosine x equals 1. And here we end up with what is a very common student mistake, usually under the stress of trying to solve things on tests or under other conditions, because we apply what is called the zero principle, but to a thing that isn't true. So the thing that's going on here is we say, oh, if two numbers multiply to give 1, then maybe one of them has to be 1. So either sine of x equals 1 or cosine of x equals 1. And then we would say, well, then x is, say, 90 degrees, or x is 0 degrees. And we'd be, quote unquote done. But if we look back here and we say, is this true? Well, if we plug in this top guy and we check it, we say sine of 2 times 90 degrees minus 1 equals sine of 180 degrees minus 1 equals 0 minus 1 equals minus 1. That doesn't solve the equation. And if we try the other one and we say sine of 2 times 0 degrees minus 1, which is sine, of course, of 0 minus 1, which is also 0 minus 1 or minus 1. So it looks like something's gone wrong, that algebra has failed us, or trig has failed us, or something has failed us. But what's actually gone wrong is that you really can't use this as a factored thing because it doesn't obey the actual mathematical principle. Instead, we're going to leave the sine 2x as it is, and we're going to solve over and say, well, sine of 2x equals 1, which means x is a number such that twice that number when we take the sine gives us 1. Well, the angle whose sine is 1 is 90 degrees, so we'll say that 2x is 90 degrees. That's the solution to the existing equation, and from here we can, of course, just divide by 2 on both sides, and we end up with that x equals 45 degrees. And we can go back and say, well, is that really true? Let's check it. Sine of 2 times 45 degrees minus 1 equals sine of 90 minus 1 equals 1 minus 1 equals 0. So, yay, that worked. Also, if we go to our other equation that we found before, that 2 sine x cosine x should be 1, and we plug in 45, so we're saying 2 of sine of 45 degrees cosine of 45 degrees, which is 2 times the root 2 over 2 times root 2 over 2, which is 2 times 2 over 2 times 2, or 1, as we would hope, and again we get the correct solution. So we're pretty sure 45 obeys in either form the correct equation. And in fact, x equals 45 is in fact the principal value that solves sine 2x minus 1 equals 0.